Zzzpedia presents Nighttime Knowledge, the science of sleep. Tonight, you are going to do something you have done every night of your life. You will lose consciousness. Your body will go still. Your muscles will relax. Your sense of the room around you will fade until it is gone. The temperature of the air, the sounds beyond the walls, the weight of the blankets, all of it will dissolve. And for the next 7 or 8 hours, you will be somewhere else entirely. Somewhere you will not remember in the morning. This happens to every person on the planet, every night. It has happened to every human who has ever lived, and for most of history, no one had any idea what it actually was. Sleep was considered a blank, a nightly shutdown, an absence, a void between one day and the next. The ancient Greeks thought it was caused by blood retreating from the surface of the body, draining inward, leaving the brain dim and quiet. Others noticed that the skin cooled during sleep and assumed the cooling was the cause rather than the symptom. For thousands of years, the best explanation for what you are about to experience was that your body simply turned itself off. That assumption was not just incomplete, it was almost perfectly inverted. What is about to happen to you is not a shutdown. It is one of the most intricate processes your body performs. It took a century of science to even begin describing it. A refugee who built a laboratory no one wanted, a broken machine in a university basement, a child falling asleep on an army cot while his father watched the graph paper and tried to understand what he was seeing. As one researcher observed, the state of knowledge was analogous to going to Mars with a third of the Earth's surface still unexplored. Every human being slept. Almost no one had looked at it carefully. Before the Industrial Revolution, before electric light, many people slept in 2 shifts. They would go to bed at dark, sleep for several hours, wake for a quiet interval, and then sleep again until morning. The pattern was so ordinary that it barely warranted mention. When modern researchers place subjects in 14 hours of darkness, mimicking those long pre-industrial nights, the 2-shift pattern returned on its own. The body remembers what the light bulb made it forget. But even this, the simple architecture of when humans sleep, was not studied seriously until one person decided to try. In the 1920s, at the University of Chicago, a man named Nathaniel Kleitman did something his colleagues considered pointless. He devoted his career to the study of sleep. Kleitman had arrived in America as a young man of 20, penniless, fleeing pogroms in what is now Moldova. He earned his doctorate at Chicago, summa cum laude, and then turned his attention to a subject no one else was willing to take seriously. He built what is described as the world's first sleep laboratory, filling it with instruments he designed himself. By most accounts, he was the only person on the planet giving sleep his full professional attention. The field was considered scientifically trivial. His reasoning was simple and elegant. He explained it in his own words. I was interested in the state of consciousness and how it operates in a human being. I thought, if we know something about the state of unconsciousness, not anesthesia, but normal unconsciousness, which is sleep, we may be able to derive an opinion as to what makes the conscious brain operate. To understand the waking mind, study the moment it disappears. It was an inversion so clean it almost sounded obvious, except that no one else had thought to do it. In the summer of 1938, Kleitman and a graduate student named Bruce Richardson descended 140 feet into Mammoth Cave in Kentucky. They would stay underground for 32 days. Their question was whether the human body keeps its own time or depends entirely on the sun. The chamber they chose was called Rafinesque Hall, a cathedral of rock, 26 feet high and 65 feet wide, buried deep beneath the Kentucky hills. The temperature held steady at 54 degrees, cool enough that both men wore layers constantly. There was no natural light, none at all. When they extinguished their lanterns, the darkness was total and immediate. No fading twilight, no ambient glow, no difference between having your eyes open and having them closed. And it was silent. No birdsong, no wind, no traffic, no indication of whether it was noon or midnight on the surface above. Just rock and stillness and the sound of two men breathing. Their furniture was a table and a bunk bed. The beds had been shaped into shallow bowls, a precaution Kleitman devised to keep rats from climbing in during the hours of complete darkness. Meals arrived from the Mammoth Cave Hotel, carried down by staff. Fried chicken and hickory-smoked country ham became their greatest single pleasure. Cigarette packs accumulated on the breakfast table. Every 2 hours, each man measured his own body temperature with an oral thermometer, tracking the tiny rises and falls that mark the body's internal rhythm. The plan was to live on a 28-hour day, 9 hours of sleep, 10 hours of work, 9 hours of rest, timed by an alarm clock rather than the sun they could not see. Each cycle they would measure and record, eat and work and sleep again, trying to push their bodies onto a rhythm that had no basis in nature. The question was whether the body would follow the artificial schedule or insist on its own. After 32 days, the answer was clear. Richardson, the younger man, adapted. His temperature rose and fell in time with the 28-hour cycle, as if his body had accepted the new day without complaint. Kleitman's body refused. No matter what the alarm clock said, he grew tired at what would have been 10 in the evening on the surface, and alert again 8 hours later. His internal clock held firm, indifferent to the schedule imposed on it. Kleitman took the result with characteristic understatement. It merely shows what has been known for a long time, that some individuals can change their habits with ease, while others find it very difficult to do so. The cave had proven something fundamental. The body does not wait for the sun to tell it when to sleep. It carries a clock of its own, a rhythm woven into its biology, so persistent that 32 days in total darkness could not override it. Sleep operates on a schedule the body itself is keeping, somewhere deep in its architecture, ticking steadily whether or not there is a sky to tell it the time. But the cave had only answered when the body sleeps. It had said nothing about what happens once sleep arrives, what the brain does during all those hours, what purpose the darkness serves. That question would be answered in a very different kind of darkness. Not a cave in Kentucky, but a second-floor laboratory in Chicago, by a man with a broken machine and a child who was falling asleep. Something is already changing in you as you listen to this. It may be subtle enough that you have not noticed. Your body temperature has begun to drop. Not much, roughly 1 degree, but the decline is deliberate and precise. Your heart rate is slowing. The muscles in your arms and legs are releasing tension they carried all day, and the electrical activity in your brain is shifting. The rapid, irregular firing of the waking mind, what scientists call beta waves, is smoothing out, settling into longer, slower patterns. This is the threshold, the place where thoughts begin to loosen and fragment, where images appear that you did not choose, where the line between thinking and dreaming starts to dissolve. This has been building all day. Since the moment you woke this morning, a molecule called adenosine has been accumulating in your brain, a quiet byproduct of every hour spent awake, every thought, every effort of attention. It binds to receptors and creates a pressure that grows steadily heavier as the day goes on. Coffee blocks it for a while. Distraction holds it at bay. But it does not stop building. By now, after a full day awake, the pressure is at its peak. But pressure alone is not enough. The body also needs a signal that the time is right. Deep in the brain, just above the place where the optic nerves cross, sits a tiny cluster of neurons called the suprachiasmatic nucleus. It is the clock that Kleitman could feel, but could not see. When darkness comes, it sends a signal to the pineal gland, releasing melatonin into the bloodstream. Melatonin does not make you sleep. It tells the body that the conditions are right, that darkness has arrived, that the day is over, that the gate can open. The pressure has been building for hours. The signal has been sent. The two systems are converging right now within you. Beyond this threshold, the descent continues. The brain's waves lengthen further, through the rolling patterns called theta waves, and down into the deep, powerful delta waves of slow-wave sleep. These are literal waves, measurable on an electroencephalograph. Millions of neurons firing together in synchrony, producing a slow, coordinated pulse that looks nothing like the scattered activity of the waking brain. In the deepest stages, the outside world does not vanish entirely. A loud sound could still reach you, but the brain has raised its threshold. What would have caught your attention minutes ago, now, passes without trace. Sleep is not one state, it is an oscillation. Every 90 minutes, the brain moves through a cycle of stages, descending into deep, slow-wave sleep, rising back toward lighter phases, and then entering a state so different from everything else that when it was first discovered, the scientist who found it was sure his equipment had broken. Each cycle lasts about 90 minutes. 4 or 5 will unfold before morning. In the early cycles, the deep, slow wave phases dominate. Later, toward dawn, something else takes over. Something no one knew existed until the middle of the 20th century. In the early 1950s, a graduate student named Eugene Azarinsky was working in Kleitman's laboratory at the University of Chicago. He had been assigned to study the slow eye movements of infants as they fell asleep. It was not a prestigious project. The equipment he had to work with was an Offner dynograph, an aging electroencephalograph he had hauled up from the basement of Abbott Hall, a machine so temperamental it broke down constantly. Zzzpedia spent weeks tinkering with it, coaxing it to function. One evening in late 1951, he brought his 8-year-old son Armin to the lab. Abbott Hall had the gray stone gloom of an old university building, quiet at that hour. Armin sat on an army cot, while his father scrubbed his scalp and the skin around his eyes with acetone, then carefully taped electrodes into place. The machine waited in the adjacent room, its pens resting above long banners of graph paper that would unfurl slowly through the night. Zzzpedia calibrated from next door, asking the boy to look left, right, up, down. Then Armin closed his eyes, and after a while, he fell asleep. For hours, the pens traced the pattern Zzzpedia expected. Slow, steady waves, a sleeping brain. The record scrolled out in long, gentle curves across the paper. Then, without warning, the pens began to swing. Rapid, sharp movements, peaks and valleys that looked nothing like a sleeping brain. They looked like the record of someone wide awake. Zzzpedia walked into the room, expecting to find Armin sitting up, eyes open, restless. The boy's eyes were closed. He was deeply asleep. Zzzpedia did not know what he was seeing. He assumed the machine was malfunctioning again. The leading authority on electroencephalography, when consulted, suggested abandoning the project entirely. But Zzzpedia repeated the experiment. He repeated it again. Kleitman, skeptical, insisted the recordings be replicated on his own daughter Esther. The results held every time. What Zzzpedia had found was a hidden state inside sleep. Periodically through the night, the sleeping brain erupts into activity as intense as waking. The eyes dart back and forth beneath the closed lids in rapid, jerky movements. The heart rate quickens. Breathing becomes irregular. And the body, paradoxically, enters near-complete muscular paralysis. The brain apparently awake, the body still asleep. Scientists in the late 1950s would call it paradoxical sleep. A student of Kleitman's named William Dement gave it the name that endured: rapid eye movement sleep, or REM. When researchers woke subjects during REM, the subjects almost always reported dreams. When they woke subjects during other stages, dreams were rare. The hidden state was the neurological home of dreaming, something that happened every night in every person, and had gone entirely unnoticed until a graduate student watched pens swing upon graph paper while his son slept on an army cot. Zzzpedia was a difficult man who felt, for the rest of his life, that others received credit for what he had found. But the finding itself was beyond dispute. Sleep was not empty. It was not passive. It contained a state of intense, structured brain activity that had been invisible for all of human history. Invisible because no one had thought to watch a sleeping brain closely enough to see it. REM revealed that sleep was full of hidden work, but it raised a question that would haunt the field for decades. If the brain is this active during sleep, cycling through stages, firing in synchrony, generating elaborate dreams, maintaining an architecture so precise it repeats every 90 minutes, what is all of it for? Why does the brain need to do this at all? For 50 years after the discovery of REM, science had no good answer. The only known function of sleep, one researcher quipped, was to cure sleepiness. The evidence for what happens without sleep was vivid enough. In December of 1963, a 17-year-old in San Diego named Randy Gardner decided to find out. It was a science fair project. Gardner later recalled his confidence. "I wanted to prove that bad things didn't happen if you went without sleep. I thought, I can break that record, and I don't think it would be a negative experience." He stayed awake for 11 days. By the third day, he was nauseous and his memory was failing. By the fifth, he was hallucinating, his speech slurred, his sense of reality loosening. William Dement drove down from Stanford to monitor the experiment and kept Gardner going by playing basketball and pinball. Gardner beat Dement at pinball every time, even as his sentences stopped making sense. By the final days, his motor control was failing, and his brain was seizing tiny involuntary moments of sleep. Micro-sleeps lasting only seconds, the brain stealing back what it desperately needed. Asked to count backward from 100 by sevens, he stopped at 65 and forgot what he was doing. After 11 days and 24 minutes, Gardner held a press conference. He appeared alert. Then he slept for 14 hours and 46 minutes and another 10.5 hours the following night. His brain recovered, but the experiment had made something plain. Without sleep, consciousness comes apart. The mind does not simply get tired, it dissolves. Whatever sleep was doing, the brain could not survive long without it. The answer came quietly 50 years later from an unexpected direction. A neuroscientist named Maiken Nedergaard, working at the University of Rochester, had been studying a problem no one had paid much attention to. Every organ in the body produces metabolic waste, the byproducts of all that cellular work. Every organ has a system to remove it. The lymphatic system handles most of the body's cleanup, but the brain has no conventional lymphatic system. For years, no one could explain how the brain took out its own trash. Nedergaard's team found it. The brain has its own waste clearance network, a system of channels running along the outside of blood vessels, using cerebrospinal fluid to flush debris out of the tissue. They named it the glymphatic system. It had been invisible to researchers because it could only be observed in the living brain, with imaging technology that did not exist until recently. Then, in 2013, her team published a finding that changed the conversation entirely. The glymphatic system is almost 10 times more active during sleep than during waking hours. The mechanism is physical, and the image it produces is striking. During sleep, the spaces between brain cells expand by roughly 60%. The cells themselves pull back slightly, opening channels that are squeezed tight during the day. Into those widened gaps flows cerebrospinal fluid, moving through the newly opened pathways, washing away the metabolic waste that accumulated during every hour of waking thought and perception and memory. Among the waste products being carried out is amyloid beta, the protein fragment whose buildup is associated with Alzheimer's disease. The picture is almost mundane in its clarity. During the day, the brain works and produces waste. During sleep, the brain opens itself up and rinses the waste away, like a building that can only be cleaned after the workers go home. The hallways need to be empty before the cleaning crew can get through. Nedergaard put it plainly. The restorative nature of sleep appears to be the result of the active clearance of the byproducts of neural activity that accumulate during wakefulness. Research since has reinforced the connection. Poor sleep is associated with greater accumulation of amyloid beta. Even a single night of sleep deprivation can elevate its levels. The relationship between chronic poor sleep and the risk of neurodegenerative disease is now one of the most active frontiers in brain science, though researchers are still working to untangle exactly how the causation runs. What is clear is that the brain treats sleep not as rest but as maintenance, essential, structured, and irreplaceable. For thousands of years, the question of what sleep is for had no answer. The Greeks thought the body was shutting down. The 20th century discovered it was full of stages and dreams and cycling architecture. And then, in 2013, the simplest answer arrived. The brain gets dirty during the day, and sleep is when it cleans itself. The question that sent a man into a cave for 32 days, that kept a graduate student up past midnight, watching his son's eyes move, that drove a teenager to stay awake for 11 days to prove nothing bad would happen. The question finally had an answer. And the answer was not abstract or philosophical. It was not even elegant. It was plumbing. The brain fills up with waste, and sleep is when the water runs. You may already be feeling it. The settling. The way your thoughts have started to move more slowly, to connect less precisely. The heaviness that does not come from anywhere in particular. It just arrives. Your body temperature has been falling since you lay down. Your heart rate has slowed. Somewhere deep in the architecture of your brain, the signals that kept you alert today are fading, and a quieter process is taking over. What you have been hearing about tonight is not a story that happened to other people in other places. It is a description of what is happening to you. The temperature drop is real. The shift in your brain's electrical activity is real. The threshold you are approaching, or may have already crossed, is the same threshold that Kleitman spent his career trying to understand, the same one his student son crossed on an army cot in 1951, while the graph paper traced the moment it happened. Within the hour, the slow waves will begin. Your neurons will start to fire in long, rolling synchrony, and as they do, the spaces between your brain cells will widen. Cerebrospinal fluid will flow into the gaps, moving through channels that have been closed all day, carrying away the molecular residue of everything you thought and saw and remembered since you woke this morning. This will happen quietly. You will not feel it. You have never once been awake to notice it. It will happen 4 or 5 times tonight. Each cycle will take about 90 minutes. In the early hours, the slow wave phases will dominate, the deep cleaning. Later, your eyes will begin to move beneath your closed lids, and your brain will light up with the strange private intensity of REM. You will dream. You may not remember it. The thing that feels like nothing, the hours that will disappear, the time you will not account for, turns out to be the most elaborate thing your body does. a process so essential that evolution made it irresistible, so ancient that every animal with a brain performs some version of it, so quiet that humanity studied it for a century before understanding what it was for. You will not be awake for any of it. You never have been. Every night of your life, the most extraordinary thing your body does has happened without you there to see it. And tonight will be no different. It may be happening right now.